Welcome to Effortless Mastery. Have you ever thought about how the glycogen that's being stored in the body is being broken down? Have you ever thought about how the body survives during periods of starvation? Those moments we don't have what to eat, or after sleeping for a long time, you ate last in the evening. How is your body able to sustain you to the next morning? Or at other moments when you are starving, how is the body able to break down what was stored to give energy? That's what we want to learn today. And it is in a topic called glycogenolysis. Now, from the word, it's easy to define glycogen lysis. So, glycogenolysis is the breakdown of glycogen. The breakdown of glycogen. To release, of course, in this, it's aimed at releasing glucose and, of course, leading to energy formation, whether in the tissue or cell that broke it down or somewhere else. But the aim right here is always during moments we need them. So now let's go on. Now, glycogenolysis occurs primarily in two sites, just like glycogenesis, the liver and the skeletal muscle. But also it could happen in the kidney. It's one of the things that could happen in the kidney. But primarily the two places I'm looking at is the places that were stored, which was liver and skeletal muscle. If you are yet to watch our video on glycogenesis, you should go back and look at it. It clearly explains how storage happened. But at the moment, you can still watch this as a standalone while before you go back to look at how it is formed. Now, so glycogenolysis is a breakdown of glycogen, usually to give glucose or aimed at formation of energy. Now, the key enzyme in this pathway is called glycogen phosphorylase. And remember we said that two primary locations glycogenolysis can happen. Please, the enzyme is called glycogen phosphorylase. Now, the name phosphorylase. Now, there are three enzymes with the three sets of enzymes that have to deal with anything concerning phosphates. And those set of enzymes, so number one is kinase. We've talked about kinase a lot in our series on metabolism of carbohydrates, talking about them as people that transfer phosphates. So they transfer phosphates. Before I say something is transferred, that means it's leaving someone and going to another person. Usually, the person that donates this phosphate is ATP. So they transfer phosphate from someone to another. So we call them kinases. But now, this is another type of enzyme I'm introducing you to today called phosphorylase. Phosphorylase, their action is that they add phosphates to a compound, and the aim of this addition of phosphates is to lyse that compound, to break down that compound, to bring out something from that compound. So while kinases donated to you from the goodness of their hearts, phosphorylase are given to you because they want to get something from you. So that is glycogen phosphorylase. And from their name, if there are people that give phosphates, they are only active when they are phosphorylated. Remember we said glycogen synthase is only active in dephosphorylated states. But when I come here, my glycogen phosphorylase is only active in phosphorylated states. When it is phosphorylated, that is when it is active. All right, so those are things to note as a background. Another enzyme we'll need here will be the branching enzyme. Remember we established that glycogen formed is always having, that the glycogen we form in the human body is in this pattern. You realize that I form a glycogen that has straight chain and branch chain. The straight chain was alpha 1,4 glycosidic bond formed by an enzyme called glycogen synthase, whereas the branching was brought about by an enzyme which is alpha 1,6 glycosidic bond was brought about by an enzyme called branching enzyme. So on the other hand, the opposite or the direct antagonist of glycogen synthase is glycogen phosphorylase. So you'll be breaking down those 1,4 bonds. Whereas the direct antagonist of branching enzyme is an enzyme we call debranching enzyme. So what does it do? Very simple. Let's now go into the pathway. Of course, here we are trying to break down. Of course, in one of our videos, our next video, we'll be talking about how we regulate glycogen metabolism. So that will give you an idea into what will cause activation of these enzymes. I will talk about them there in a separate video. But for today's class, I will start up with the breakdown. So when I'm starting with breakdown, I'm looking at starting from who? Glycogen. Now from glycogen, an activated glycogen phosphorylase. Remember, I called him a phosphorylase. I said it's activated only when it is phosphorylated. So if my action is to add phosphate to a compound to split something, that means I can only be active when I have that phosphate available. So what it does is that he goes to an already present glycogen and facilitates addition of inorganic phosphates. And the aim of this is that from a glycogen that had maybe n number of glucose molecules, I will now be having a glycogen that has one less, that a glycogen has lost one glucose. So let's say here it was 100 molecules of glucose. Right here, I will now be having 99. And the glucose will come out as glucose 1-phosphate. Please observe every single step I'm mentioning here. So you observe that the action of glycogen phosphorylase is to add inorganic phosphate to glycogen aimed at removing glucose 1-phosphate, so that what I'll have left will be a glycogen that is deficient of 1 glucose. I'd love to show something very quickly before I go on with my pathway. And this is the template. If you still remember, we had a primer, all those things when we were doing synthesis. But the key thing was that I'll just use it this way. I kept having glucose. Forgive my diagram being this way. This is not how I want it, but I want them to use them this way so that I can explain what I need to explain to you. Now, from here, the key thing is that I must have branching too. Yes. So you need to remember that. So of course, they're usually longer than this. I'm just trying to be a bit considerate with the space and with the time we have. So you see, this is what I call a glycogen molecule. Of course, there are a lot of branching between the 6 here and another set of people. So you keep having a lot of this. Of course, all of these places, you know where oxygen should be. So, but there's no time for that. Now, what's the action of glycogen phosphorylase? His target is not 1,6 bond, which was formed by branching. His target is 1,4. These bonds here. That is his target. So the bonds that were formed by glycogen synthesis is what he's targeting. And what does it do? When he comes in, he attacks this bond in a very wonderful way. There's a particular scenario that comes to my mind when I think of what he does. Now, we have people that were holding hands together. Let's say, just had a series of friends that were holding hands together, and I want to draw one of them out. I know he likes probably football. So they were just there seated together or holding hands together. And all of a sudden, I throw football towards him. Or maybe I know he likes maybe food or one thing or the other, orange. You throw it towards him. You realize for him to catch that orange, he needs to leave whosoever he was holding. And he catches the orange and it comes out. That's the same thing that happens. So what does this guy do? He brings in inorganic phosphates. And a glucose molecule here will leave his guys. He will leave this bond to go and catch the phosphates. And it will come out as glucose 1-phosphate. And what am I left with? A glycogen that is deficient of 1 glucose. That's the best scenario you can have it explained. So, such that the addition of these phosphates is the enzyme knows that that glucose likes phosphate. So when he brings in phosphate, glucose will forget he was in a structure he was being bonded. He will break that bond quickly. What is he doing? To go and collect the phosphates, and it comes out as glucose 1-phosphate. Now, after this has happened, so you realize the action of glycogen phosphorylase is to produce glucose, not as free glucose, but rather as glucose 1-phosphate. Now, the other enzyme we call is debranching. But let me mention how debranching comes in. The stuff is that, usually remember these things, the straight chains are usually very long. So glycogen phosphorylase will keep acting and acting until I have about 4. My structure is not clearly depicting it. So if I was having them like 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all bonded together, what will he do? He keeps taking them out. 2, 3, 4, 5. I keep breaking them one after the other. By the time around a branching like that, by the time I go to a branching and I keep breaking and breaking, and I just have 4 persons left around that branch chain. I don't know if you're understanding me. Now, glycogen phosphorylase breaks alpha 1 4 bond. That means I'll keep breaking the bond between number 1, that's between 2 people that are in straight chains. But as I keep breaking, they're always very long. I keep breaking and breaking till I have just 4 persons. 4 here and 4 here being joined together by a bond. Now, what happens right here is that another enzyme comes in, and that enzyme, different books give it different names, but I like a name. One of the names beta use, or I would love you to use, is alpha 1,4 alpha 1,4 glucan transferase. What does it do? It comes to where I had 4 people. Remember, I had 1, 2, 3, 4. It breaks the bond here, and it transfers this 4 to this other person. So this one was 4 before. You were 4. So me, I come here, break the bond between. Please observe what I'm taking out. I'm taking out 3 glucosyl units. I'm not taking 1. The person that was breaking them in ones was who? Glycogen phosphorylase. He adds phosphates, takes out 1 person. Add phosphates, take out 1 person. But I have another enzyme coming in. Please, I said the name of the enzyme is alpha 1,4 to alpha 1,4. That means I'm breaking a bond of alpha 1,4. Now, or some people, we don't need to mention this, but the key thing here is if you can have alpha 1,4 glucan transferase. Now, from the name, I am transferring glucose units. Where am I transferring them to? To try reversing what we did. If you remember, when we were forming glycogen in our video on glycogenesis, look at what we did. We mentioned that I form glycogen synthase will elongate. As it keeps getting longer and longer, branching enzyme will come and cut and take to another place. So right here, we are trying to reverse that. When I'm trying to now break down the glycogen, what I do is that first, I'll go to some way, cut and come back to elongate. So I am cutting here to go back and elongate this one. So if they were 4, 4, to now be 7, 1. Now, the next thing that now happens is that branching enzyme. So what has happened is that following the action of this enzyme called alpha 1,4 glucan transferase, this place is now exposed. The bond is now exposed, and the other enzyme comes in, and that enzyme is called the branching enzyme. So when the branching enzyme comes in, it releases glucose. Remember, the branching enzyme does not need to add phosphates. So to just break the bond, the alpha 1,6 glycosidic bond, and releases glucose as free glucose. Please, key things to note. So there are 3 enzymes here I've mentioned. Number 1 was what? Glycogen phosphorylase. What does it do? To these long chains, I just add phosphates and I pick up glucose. I keep taking out glucose individually as glucose 1 phosphates, not free glucose. Please take note of that. I keep taking them out as glucose 1 phosphates. And every single time I take them out that way, I keep reducing the length or the number of glucose molecule in the glycogen. But as I keep reducing and I have 4 on either side of a branch. Remember what we call this, what was responsible for this branching was a bond we call alpha 1,6. By the time I have 4 on both sides, phosphorylase can no more act. The enzyme we bring in here first is an enzyme we call alpha 1,4 glucan transferase. What does this enzyme do? It transfers 3 glucose moieties or 3 glucose subunits, glucosyl units, 1, 2, 3, from here, and chooses to now use them to elongate an already present pathway. So that if I go and elongate there, phosphorylase will be acting on them and cutting them on that side. So I'll cut this, you go and elongate there. So you keep cutting them on that side, keep cutting them. And by the time I do that action, who is doing it? Alpha 1,4 glucan transferase is transferring something. Now I am now left with maybe a long chain and then this bond just bounded to one glucose moiety. So that means I have exposed this bond to be broken. And the person responsible for breaking alpha 1 6 glycosidic bond is the branching enzyme. So that is that. So you realize that after I break that bond, this thing is now just one straight chain. So you keep breaking and breaking. Who will be breaking? Glycogen phosphorylase. You get to where you have 4,4. Then I transfer 3 to elongate the other person. Use the branching. Who transfers 3? Alpha 1 for glucan transferase. So I cut it here. Why the name was given alpha 1 for is that I'll break it here. I don't want to use it that way, but you can also use that. It is better that way. I break it from an alpha 1,4 bond, carry him to go and form another 1,4. So I'm transferring him from where it was 1,4 to go and do another 1,4, and then expose this place for the branching to act. So these are the 3 enzymes we use in glycogenolysis. Now, but of course, this has not ended because glycogenolysis is aimed at formation of glucose. So from here, our glucose 1 that is formed is converted to glucose 6-phosphate, and the enzyme is called phosphoglucomutase. Remember what we said, it is irreversible, just change in position. And so it changes from 1 to 6. Now, this glucose 6-phosphate, the effect of glucose 6-phosphate formed from glycogenolysis is different in different sites. For example, in the liver, we have an enzyme called glucose 6-phosphatase. Now, this now mentions the third person that can deal with phosphates. Now, I've mentioned 2 enzymes already, kinase, phosphorylase. Now, the third one is what? Phosphatase. What does a phosphatase do? It adds water and break out phosphates. So it is used to remove phosphates from a compound by addition of water, by hydrolysis. So what happens is, in liver, I have this enzyme, but in muscles, I don't have this enzyme. So what we will now see is that in liver, this enzyme will act and I'll have glucose formed, please, in liver. So what happens? Water is added and then inorganic phosphate is removed. Please, what did I call the enzyme? The enzyme is called glucose 6-phosphatase. So that is that. Whereas in skeletal muscles, these glucose 6-phosphates cannot be broken down because this enzyme is absent. Rather, glucose 6-phosphate is used straight into glycolysis. So that person that was running in need of energy will just use the glucose 6-phosphate at once for glycolysis. But what is important about this stuff, what is important about the action of glucose 6 or the case is that in some conditions, when I sincerely or the body really needs glucose 6, when it enters glycolytic pathway, can form pyruvate. Pyruvate can change to lactate. And via a cycle we call Cori cycle, it can be recycled. That is, the lactate can be carried to the liver, that is into blood to the liver, and within the liver, it will be converted back to glucose to form glucose, if the body must form glucose. But outside that, most times in the skeletal muscle, glucose 6 is just used for energy. So that brings us to the end of glycogenolysis. So what are we to take note of? Or what are the key takeout points in glycogenolysis? The key takeout point is that glycogenolysis is breakdown of glycogen. Occurs majorly in liver and skeletal muscles. It can also happen in the kidney. Now, the enzyme or the key enzyme here is called glycogen phosphorylase. And this enzyme, when it is found in liver, we call it liver phosphorylase. Found in muscle, we call it muscle phosphorylase. The enzyme is active only when it is phosphorylated, and it catalyzes the first step whereby glycogen is broken down. How? The enzyme adds phosphates to a chain of glycogen, and I told you that once it adds phosphates, it gives it to one of the glucose. Let's say at this end, I give him phosphate. By the time I give him phosphate at position 1, he breaks the other bond and comes out as glucose 1-phosphate, and I have glycogen deficient of 1 glucose. So the action of glycogen phosphorylase will keep happening and happening till I have 4 on either sides of a branch. Remember, it is glycogen, and one of the key things about glycogen is that it is not just straight chain, there's also what? Branching. So I have now 4 on either side. Now, what is responsible for breaking that one would have been the branching, but the branching is not called in immediately. So I need to first cleave out 3. So out of the 4 on either side, a second enzyme comes in called alpha 1,4 alpha 1,4 glucan transferase. So I will break a bond between alpha 1 and 4, transfer 3 glucose moieties to an already present place to now elongate it, forming another alpha 1,4. So that's why they call it alpha 1,4. I'm splitting at an alpha 1,4 to transfer to somewhere I will still form alpha 1,4. That means this enzyme is doing elongation. Cut and go and elongate somewhere else. And then what we will now have is that I will now be having a free glucose attached by branching to an already present long chain. And the enzyme that now comes into action is called the branching enzyme, an enzyme that can cleave that bond. It cleaves the alpha 1,6 bond. And by that action, I now have free glucose release, please. So action of the branching enzymes releases glucose as free glucose, whereas the action of glycogen phosphorylase releases glucose as glucose 1-phosphate. And if we are looking at the one form from here, glucose 1 is converted to glucose 6, mutase, and glucose 6 in liver is broken down to give glucose, but in skeletal muscles, it is used directly for energy, glycolytic pathway. And if need be that it is used for glucose, it has to be, the pyruvate form has to be converted to lactate, and using Cori cycle, it should be recycled to the liver, where glucose is now formed back again. So that brings us to the end of glycogenolysis, a process whereby the body during fasting states or during starvation states breaks down glycogen to release glucose, either as free glucose, as in the case of a liver, whereby whatever you were doing with the enzymes ends up giving you free glucose that the liver can use and can also give to other people to use. Or it can give you glucose 6-phosphate in the case of the skeletal muscles where it is used directly for energy. So thank you very much for joining us today. I will see you in our next class. In our next class, we'll be discussing on the regulation of glycogen metabolism as a whole. I'll see you in our next class. Please go ahead and subscribe to this YouTube channel, hit the notification button, and then like this video. Stay connected as we keep bringing up premium things. In our videos, we are aimed at ensuring that you understand at all costs.